So definitely appreciate all of your time. I know time is precious, and if you guys are like us, you are very, very busy, and so taking time out to spend time with us and learn more about SIM is important. And so I appreciate that. I'm going to talk about the SIM and why do I need it, and I think more importantly, why do your customers need it? At the end of the day, we're going to walk through some data points, and hopefully it'll help solidify why this is necessary, especially as we start to see more and more regulatory pressure being put on our customers. So I'm not going to jump that far ahead, but I do want to talk a little bit about, as soon as my machine catches up, there we go. HighWire Networks. For those of you who don't know us very well, we've been around for 20 years. We do a lot of different things. We have 3 lines of business, and I'm not going to go into all of them. I think the most important thing to note about what we do is we partner with you in serving your customers. So to us, you are our customer, and we do our best to deliver services that your customers want to pay you for. So we've been doing that for 20 years. Cybersecurity is about a 3-year-old part of our business. We have a security operations center in Batavia, Illinois, where we manage risk for our customers, for you and for your customers. So just a high level what we do. If we want more details, we can go to the HighWire website. But for this purpose is just a quick high level what we do. Having said that, I want to talk about the SIM, right? The logging challenge that we have. I'll walk you through what that looks like. What is a SIM? Some folks don't even know what it is, let alone how to pronounce it. It's funny. We have folks who pronounce it as SIEM and some who pronounce it as SIM. So we can talk about that as well. What an architecture looks like and why it's important. And what are the business drivers that are pushing your customers to ask you about, hey, do you guys offer managed SIM? The single pane of glass idea, and then I'm going to walk you through briefly what our platform does in delivering managed SIM services to you and to your customers. If at any time, excuse me, you have questions, feel free to add them to the chat, and Susanna will interrupt me and ask me to answer them. So I have no problem doing that. But I wanted to give you just some idea, and I'm not going to read all of this, but just to give you some context, right? Every system that you use, whether it's your phone or your tablet or your PC or your Mac, all the way down to your servers and your routers and your switches, they all, and your firewalls and all your security controls generate log data, right? And so just to give you some idea of why you need a SIM is this idea, the logging challenge. Excuse me. So if you think about a word, a typical word is about 5 characters plus a space. If you can do 200 words a page, that is roughly 894,000 pages in a gigabytes of traffic, okay, or gigabyte of data. What that equates to is, think about the man hours required to read 900,000 pages. It's impossible. And if you extrapolate a little bit further, there are companies out there. I had a meeting with a bank in DC, a very large multinational bank. And I said, how much data are you ingesting in a day? And he said about 4 terabytes of data. So 4,000 times the 9,000 pages of text is what they get in a day, right? That gives you some volume. There's no way they can staff, let alone find the people to manage and respond to 4,000 pages of text. Or wait, 4,000 times 9,000, 900,000 pages of text. There's no way they can staff that. To give you an idea from a scale, the next paragraph, you know, a Stephen King novel is about, you can fit 500 Stephen King novels in 1 gigabyte of traffic. Again, extrapolate that towards the 4 terabytes a day, you can't read it all. And then I like that last stat in there. You know, the Webster's College Collegiate Dictionary, 10 million characters. You can have 100 dictionaries in a gigabyte. That'd be 100,000 dictionaries in a terabyte, and 100,000 physical dictionaries, if we stacked them up, would be 3.2 miles high and weigh 250 metric tons. This is a day's worth of traffic, right? This is the problem, right? So we've got all of this noise coming at us, and we don't know how to manage it. We don't know how to sift through it. This is where traditional logging fails. Imagine trying to store all this data without some mechanism to reduce it and improve it and enrich it and normalize it. It becomes painful on a good day, right? So we'll just keep on moving. And the challenge is our folks don't understand the problem. Our leaders, you know, they just say, well, continue to ingest traffic, just continue to bring all the logs in, and we'll find a needle in the haystack. And my argument is, I don't think they understand the problem. You know, if you look at this picture, for example, these firemen don't understand the problem either. In this case, they're expecting these plastic bracers to protect their hose from a 40-ton train. It's not possible. This is akin to our leaders or our security vendors not understanding what the problem is, right? There's so much outside of the data itself that we have to understand to get value out of it. So let's talk about what a SIEM is, right? A SIEM has actually been around for more than a decade. I remember back at Sprint, when I first started doing dedicated security work, we had a SIEM, and I don't even think they make it anymore. But it's evolved a ton. And at the end of the day, security event management is part of it, right? How do I manage an event that's good or bad, right? Because there are good events and there's bad events, and we'll talk a little bit about that as well. But it's real-time event management with the security information management, which is collecting, analyzing, and reporting on the log data. This is what a SIEM is designed to do. And even then, we're still struggling with a lack of correlation. While the definition talks about correlation, most SIEMs today, unless they are an XDR, next-gen type of approach, are still struggling to give you correlation. So unless you've got regulatory pressures, there's not a lot of value. So we'll keep on going, and then we can talk about that. So let's talk about just at a high level, a quick typical SIEM architecture, right? So in the middle, you've got this giant disk. A lot of folks will tell you that's a data lake. And there's various types of data lakes out there. You know, the thing to note is Elasticsearch is the most prevalent one. A lot of folks are deploying that with the free version of it. We deploy our platform. It's got the commercial version of Elasticsearch, which means it's supported. When something breaks, we get help, et cetera, et cetera. But at the middle, you've got a lake, and a friend of mine likes to use the analogy, a data swamp. And the data lake, which is your SIEM, is where we're dumping all the data. And without good correlation and data enrichment, you have just a swamp of data, and your ability to pull data out of it is limited. But again, as we look at the architecture, you've got system logs and control alerts coming into the SIEM, right on the top left. You've got business units, network maps, business processes, locations also coming into the SIEM on the top right. If you go to the left, you've got an analyst that's asking questions. Does this log entry show legitimate activity on the network? You've got routers, you've got buildings, you've got software inventories feeding the SIEM, right? Feeding accounts receivable. On the bottom right, you've got a software inventory also feeding the SIEM. You've got, you don't see it on here, but you've got vulnerability tools feeding the SIEM. And if you go back to my data lake analogy, if we're not properly correlating data, we've got all this noise. We've got 3.2 miles worth of books stacked on top of each other, and they're useless. So at the end of the day, the SIEM is collecting all of this data, and then you must have some other things on top of it to provide value, which we'll talk about. There are lots of business drivers for a SIEM. Just some high-level ones. If you've got customers who have regulatory pressures, right? I've mentioned that briefly. Their healthcare, their banking, they may be PCI, right? They're doing credit card transactions. All of those standards, all those compliance standards have a requirement for a SIEM, or in some cases they call it log retention or logging in general. But we've already talked about why logging isn't sufficient, right? Why it doesn't work. And so compliance pressures are driving a new way to think about data, right? A new way to think about logging, which is where the SIEM comes into play. I don't have GDPR listed here, but if you've got any customers who have a multinational presence and are subject to GDPR, it spells out pretty clearly, thou must have log retention, SIEM activity, or SIEM type tools, those kind of things. If you've got other organizations that are leaning towards ISO certifications, they also spell out the requirement to have a SIEM, right? And someone to monitor that SIEM. So the other thing to note is with either of these first two bullets, there is a requirement to have someone look at it, right? The challenge is, if you remember, like the Target breach, for example, they had all the log data, but nobody was looking at it. They had terabytes of log data, but they didn't have a good SIEM that noticed this bad behavior, right? And that was because fundamentally they weren't correlating everything that they had happening. If you think back to that architecture slide I showed you, they weren't correlating user accounts with data movements, with alerts that were coming from their systems to tell them something different was happening. These compliance and certification programs are saying, look, we know you can store logs. What we really want, and you have to do, is find a way to correlate them. So another business driver is log management and retention. You may not be aware, but finance requires 7 years of log data, right? How do you store that? And more importantly, how do you quickly get through it and find those needles in the haystack? I think HIPAA has, depending on which level, n number of year requirement. Sarbanes-Oxley, I think, has a 3-year. But my point is, all of these first two bullets have some requirements around how long and how much log we retain. Another business driver for the SIEM is continuous monitoring and incident response. So I mentioned we have a SOC in Batavia. 7x24, they're monitoring all of those data feeds that we saw going into the SIEM. And then based on activities and actions and events, they take actions as well. Case management ticketing systems. And then finally, finding the policy violations and then doing the enforcement. So if I have log data that I'm now looking at that tells me that John is doing something that's outside of policy, but I have no way to enforce it, to some extent, there's no point even looking at the data. And so with a SIEM, you have the ability to go to that next level, which I'll show you in the demo. But fundamentally, you know, knowing that someone breaks the law but no way to enforce it means the law is pointless in the first place. So in this case, having a policy, being able to detect the violations, and then being able to enforce actions on that policy is one of the drivers for SIEM. Before I continue, are there any questions that have come up, Susanna?
No questions yet.
All right, well then we'll just keep on moving. So one of the things that you're starting to see with the next gen of SIEM, and I'll walk you through this slide, is you have your first line of defenders. These are typically your controls, right? These are your firewalls, your endpoint agents, your cloud, your CASB tools, your vulnerability tools, your threat intelligence. All of those are kicking out logs and packets and files to a data lake. The data lake is then taking that data that we have enriched. And when I tell you enriched, what I'm really thinking about is adding some data to an event that gives me some more context, right? So if you think about context for just a minute, let's say it's you're in your house, it's Friday night, it's 10 o'clock, and you see somebody drive by slowly, right? You're in your house, your doors are locked, you really don't, you might pay attention, but in most cases you don't. But let's change the scenario where you're coming home on Friday night, it's 10 o'clock, and as you pull up to your house, you see a flashlight shined on the wall in your house and it's dark, right? Context tells me somebody's in my house. Something different is, something bad may be happening. Most cases, maybe the power's out, maybe your son or daughter has a flashlight, they're trying to find a candle, but maybe not, right? The data lake with machine learning and enrichment of data gives us context, right? Context tells me that this ransomware, the beginning of these events is tied to a ransomware event that I can then start to take action on. So enriching that data, putting in geolocation, right? Putting in threat intelligence, putting in user data, and then running that through machine learning gives us advanced analytics that can then, via APIs, go and talk back to those control points. And so you have this loop, if you will, with a single pane of glass in the middle to manage all of those events, to manage all of those responses. What that does is it allows for a lot of different things, but I think fundamentally it allows for two stats that I like to talk to. Your customers are worried about, is there someone in my network? And so mean time to detection, MTTD, remember that, right? Because they're going to want to know, how long does it typically take for you to detect something bad? And then I think the second stat is mean time to response. how long did it take for you to kick them out of your network? Those two numbers together create a metric called dwell time, which is what it sounds like. How long do they get to dwell in my network, right? The average dwell time, according to the Verizon security report last year, was about 194 days. Yes, that's right, 194 days. Do you think you'd have any data left in your network that I didn't want if I lived in your network for 194 days? And the answer is no. I've probably taken everything you have. So the quicker we can detect them, mean time to detection, and the quicker we can respond to them, mean time to response, reduces that dwell time from 194 days down to hours or less. I worked for a company for a while, and when I first met their CISO, he says, how long do you think our dwell time is? And as I started to think about it, I said, maybe 3 or 4 hours. And he says, no, it's 30 minutes. That's a great goal, right? The only way your customers could ever achieve that, even though they, in most cases, don't know they need to yet, but as they start to experience some of these attacks, the only way they ever get to a low dwell time is having your security controls, your first line defenders, sending their data to a lake that's doing enrichment, reducing data, deduplicating, normalizing, sending that to analytics, machine learning, that is going to say this behavior is different. Let's talk back to those first line controls and put a block in place. This is the power of a single pane of glass, a fully integrated, correlated SIEM. And with that, I'll pause for a second if there's questions. All right, I'll assume there's none. Actually,
Yeah, just a reminder. Well, no, there's no question, but a reminder that all of you guys are muted, and so you have to click on the button on the bottom of your screen there called Q&A. So feel free to submit questions as David is speaking.
Okay. All right, so now we're going to go to the demo phase, and this is actually, what is that? Don't want that. This is a demo. This is not live customer data, by the way, but this is our sales demo tool that we use. But this is the same interface that our security team runs as we manage risk for your customers. A couple things that you may want to note is this tool is built to be multi-tenant, right? And so you guys will have 15 customers and you will have access to their data. They can see their individual data, but they can't see other companies' data. It's really a neat way that we've built this platform. Two is what you're looking at is a dashboard that took all of those data feeds we talked about, right? It ran them through the correlation, and the data feeds are coming from those first line of security controls we talked about, right? Firewalls, SIEM, et cetera, or firewalls, endpoints, proxies, whatever. We've run that data into the data lake. So the underlying architecture for this system is a data lake. In there, we're storing all the data, but before we store it, we do some things like add in geolocation. We add in threat intelligence, and I'm going to show you what that looks like. We add in user data, and all of that leads to advanced analytics that let me find interesting things. What do those things look like? Well, let me change that to a day. Let me get some interesting data set. So I've got a day's worth of data off of this honeypot network. So what you're looking at in the middle is a honeypot network of sensors we've deployed for the bad guys to hack into. And those hacking activities are driving our sensor data around this arc, right? Now, the one thing I'll tell you is there's not a single tool by itself that can stop 100% of everything. It's not going to happen. And so what you have to have is defense in depth. And if you think about what that means, you know, maybe the security onion is a better way to describe it. You know, onions have layers. In the middle, if you can imagine, is your data, right? And just outside that is your first level of control. And then you've got another layer of control and another layer of control. But ultimately, it's an onion, right? It's got multiple layers, defense in depth. So what we've done is we built this platform where when your customer buys this service, we have the ability to turn on about 18 different layers of the onion, if you will, when they turn on the service, right? That gets them SIEM. It gets them a response mechanism that we call SOAR, which I'll show you. It gets them all the correlation. It gets them user behavior anomalies, et cetera, et cetera. But why is all that important? So let me just walk you through. Here we have an event from this morning at 5:13 a.m. attacking one of our hosts, and this is again one of our honeypot sensors. But I'm going to show you just a quick high level. No, that wasn't what I intended. There we go. So here's where correlation comes in. So here we have a host. It's this 172.22.131.165. Because we're pulling in asset data, we know it's a Cisco router, right? We can see all of the apps that Cisco router has run over time, right? I can show you what IPs that device has had, what type of sensor. But as we look through here, what's pretty cool is I'm correlating activity in and out of that device from all of those log sources we talked about. So here we have 172.22.132.18. We've got traffic that's coming from all of these external locations: China, Japan, more China, the Netherlands, more China, United States, Japan. Not only are we seeing the traffic coming to it, we're seeing what events are tied to those activities. So we have a port scan, right? We got a handshake failure. We got another port scan, another handshake failure. As we scroll down, we see an anomaly around what country the traffic was going to. What else? We got a DNS tunneling anomaly, a couple of those. But as an analyst, now I can quickly see how an event has touched a lot of different parts of my network, right? If you think about back to that diagram I showed you, the architecture, high-level architecture, I've got log sources coming from lots of places, right? And so what we're doing is we're saying we see it over here on router A, we see it on firewall B, we see it on this endpoint, and we give you a map that shows you all those traffic elements that are happening on that particular host. Now, take it a step further, I could come over here and let's see, let's go click on one of these hosts. So here I'm actually showing you the connection between the two and what type of anomaly that we found. Again, we're pulling so much data that we're giving you, that we're correlating through this entire data lake that we talked about that gives you some value, gives us as a security team some data points that let us go and take action. So I'm going to come back to the dashboard and show you just a couple more things where having an integrated SIEM helps us, right? And I'm going to talk about user behavior. So here we have user behavior that we're pulling from Active Directory, right? Or LDAP or any other user provisioning tool that's out there. But if you look at this, what we're seeing is we have some anomalies. We have an impossible travel anomaly. And you're going to go, what does that mean? Well, I live in Nashville. It's right now it's 11 or 10:30 in the morning, and an hour later I log in from Europe, right? That's not possible. So we're correlating date and time and location, and we're coming back with this anomaly that says, hey, this looks a little bit different, right? It may not be good or bad. It's just an anomaly. It's mathematically different. Login time anomaly. I'm an 8 to 5 kind of guy. It's 2 a.m. and the system's never seen me log in at 2 a.m. Right? What we're doing there is we're in the SIEM, we're correlating all of this, and understand none of these detections would be possible without having a SIEM. Log storage isn't going to give you this. It's not going to happen without a SIEM. So user application, right? Normally I don't run Word. I do, but let's say I don't. And today I'm running Word. It's going to trigger as a difference, right? It's mathematically different. It's not bad or good. It's just different. User asset access. Normally I don't log into the finance server, but I'm logged in from Beijing. It's 2 a.m. I'm running an application to query the finance server, right? Again, back to the context conversation, guys. I've just given you some context that should make you, as a security person, go, this one looks bad. User data volume. I normally surf Facebook all day, and it's 2 gigs of data. Today, it's 100. Why? What's different? Why am I moving 100 gig of data outside the network? User login location. Again, I mentioned I typically log in Nashville, and today I'm logged in New York. It's not bad or good, it's just different. And finally, the process piece. This one's interesting. Normally I don't run Mimikatz, and today I'm logged in, and I'm logged in from China, blah, 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 and I'm running this process. All of these contexts help drive risk score, and at a certain risk level, allow us to do action. So if you remember that cycle I showed you, right, we had control tools that were sending data, that was getting into a data lake, that was running through analytics, and the analytics were talking back to those control tools. Let me just show you what that looks like. And it's called SOAR. And at a high level, we've got automation, right? And what automation does is, and I'll just show you an example. We have the ability, because all that data is normalized and sorted and categorized in the data lake, I have the ability to run a query on it, right? So I'm going to show you just a simple query that I created a while back called successful logins from Russia, right? And you may go, why do I care? Well, understand you've got customers who aren't allowed to do business in Russia, right? If they're part of OFAC, they're banks, for example. Banks have a list of countries they're not allowed to have transactions with. So let's say, and Russia happens to be one of those, by the way. I want to know if I've got any traffic to or from an OFAC country, or in this case, Russia. So I run this interval every 5 minutes. I want to run this query, which basically says, if I see a user login from Russia, let me know. And if I get a hit, what do I want to do? Well, I'm going to send an email to a list. I'm going to create a secondary response, which is via Slack message. I'm going to tell the team, hey, we just had a login from Russia. I'm going to create a third action that says, I'm going to write to the firewall, and I'm going to put a block in place on that perimeter, and I'm going to block it for 5 hours. And so what I've just done is I've created 3 responses to a simple query that every 5 minutes will run in my system And if it sees something, it's going to talk back to those control points, right? Webhook, via firewall, disable a user, et cetera, and now I've got instant, 5-minute instant, if you will, response to something bad happening in my environment. You can't get that without a SIEM, and you certainly can't get that without a next-gen SIEM that's got fully integration, fully automation back to those control points. That's pretty much the drivers, right? That's where this idea of a next-gen SIEM comes into play.
Looks like we've got one question in, David. Who needs to have SIEM in their networks? Good question.
So I think the short answer is anyone who has data they want to protect. And I know that sounds pretty simple. You know, I think there are some organizations that have to have it from a regulatory compliance perspective. We talked a little bit about that. But, you know, fundamentally, there's, for example, there's a dentist office by my house, has 6 chairs, and they suffered ransomware. And in a very short period of time, they went out of business. And so the question that I like to have people think about is, can you afford not to, right? Ransomware takes some time to propagate and cause an outage. In his case, it caused a significant outage. But can they afford not to? Now, I realize dental offices are subject to HIPAA from a compliance perspective, but there's lots of organizations that don't have regulatory pressures that still are at risk should they get a breach or should they get a ransomware event. So the short answer is and I know this may seem a little bit interesting, but I think everybody needs something looking at their log data, right? And that's where having a service that does this for a living comes into play. Understand that standing up your own SOC, if you had a customer that said, well, you know, we're really thinking about doing it ourselves, you know, minimally you need 8 to 11 people to do 7x24 monitoring, and you need, you know, $500,000 or more in investment in capital for software and facilities, and it's not an inexpensive proposition. So, you know, I think the short answer is everyone does. I see your questions, Serge. For Synex or any other partner that we have a per monthly structure that is tied to really a couple of different models that we can talk to offline. Fundamentally, you've got a user model and you've got an asset/user model together. And the reason we've done that is some assets, as you can imagine, like a firewall, kick out a whole lot of traffic and a whole lot of data versus you know, an office where you've got 10 users and all they do is email. So the short answer is it depends. The better answer is we've got negotiated pricing structures, and we're happy to walk you through those where it makes sense.
Another person has asked, can we, or do we have the ability to demo the SIEM solution?
Meaning, do they have the ability to demo it themselves?
Right.
Or...
It was a chat question, and I responded to this person saying we could probably demo with you for their clients. Is that correct?
Yes. Yeah. And we actually, you know, as we get more of your folks onboarded, we can teach them how to demo it so they can do it without us. You know, truthfully, there's a lot to the platform. And so in most cases, you're going to want us to go in with you as a partner.
Okay. Another question.
Can we?
Oh, go ahead.
I see the automated responses to malware. Is that, yeah,
Yes.
I saw that
Yes.
one. So let me come back to here, go back to my dashboard. So malware is going to show up in a couple of places. And I didn't go into the dashboard into every category, and we can do that, and that may be a better conversation for us to have individually. But if you think about malware, how it works, it's going to typically operate in one of these three categories here on the right. Installation, where the malware is trying to install. Command and control, where the malware is trying to talk home, right? Because all those malware pieces typically phone home. Or this bottom one, where the malware is actually trying to ship data out. And so we've got detections at all three of these layers, where we can detect and we can respond automatically depending upon what it is. So the response could be a simple, we see John's machine is beaconing out because it's got malware. We're going to put a block in the firewall to not allow that IP to go out the network. Right? That's one option. Option two is we could talk to a carbon black type of product or Silence, and we could tell it to quarantine the device. So the short answer is it depends. The longer answer is, depending on which controls we've got in place, the tool has the ability via webhook, via API, to affect change.
Thank you, David.